Hi there. Welcome to the content highlights for Chapter 6.4 and 9.3. In this section, we will explore inequalities, problem solving with inequalities, and temperature conversions. First, let's take a look at a basic example. To simplify this, let's first multiply through by the least common denominator in order to cancel out some of our fractions. Now, between 9 and 3, we're going to choose 9, and that means I need to multiply each term by 9. And then, of course, reduce our fractions where applicable. 9 goes into 9 completely, so that leaves us with x. 3 goes into 9 3 times, which is 3 times 7, so that's x minus 3 times 7 is 21. Less than or equal to 3 goes into 9 again 3 times, so that is 3x, plus 1 times 9 is 9. And from here, we can move around, combine like terms by getting all of our variables on one side, the constants on the other. So if I subtract 3x on both sides, and then go ahead and add 21 to both sides, that will give me negative 2x is less than or equal to 30. Now, don't forget, anytime you have a negative in an inequality and you have to divide by that negative number, or of course multiply if applicable, that requires you to flip the sign of the inequality. So because we're dividing by negative 2, when we rewrite this, it's going to be x is greater than or equal to 30 divided by negative 2 is negative 15. So the solution set here would be x is greater than negative 15. Now to graph that on a number line, I'm just going to put 15 on here, or negative 15 rather. And because it is greater than or equal to, we're going to use a bracket. And greater than, in this instance, shades to the right. So this would be the visual that represents x is greater than negative 15. Next up, let's take a look at the compound equality. Negative 12 less than or equal to 3/4 x minus 6 is less than 0. Don't forget with these that anything you do, the goal is to get the x isolated in the center. So what I want to do first is add 6 to, because this is a compound inequality, we have to add it to all three pieces. And that gives us negative 12 plus 6 is negative 6, less than or equal to 3/4 x, which is less than 0 plus 6 is 6. Now, keeping with getting x by itself in the center, how we get rid of 3/4 is multiplying by its reciprocal. So I'm going to multiply each piece by 4/3. That allows the 4/3 and 3/4 to simplify, right? So that becomes 1. So we have our x isolated in the center. This is like having negative 6 over 1, so we can multiply here, which is going to give us 3 into negative 6, and reduce first, it's negative 2, and 4 times negative 2 is negative 8. And here this is like 6 over 1, so we can reduce, 3 goes into 6 twice, and 4 times 2 is positive 8. So in order to graph this, because we're dealing with two separate things, I'm going to put a placeholder of 0 in the center and count out from there. We have positive 8, and then we have negative 8 on the left side. Now you'll notice x is being sandwiched between negative 8 and positive 8. However, it's inclusive, so we use a bracket on the left, but exclusive on the right, meaning it is not or equal to, so we use a parenthesis. So we would shade in between those two pieces. And that is what the number line solution would look like for this. Let's venture into word problems involving inequalities. On two exams you have grades of 81 and 89. There's an optional final exam which counts as one grade. You decide to take the final in order to try and get a course grade of A, meaning the final average of at least a 92. What must you get on the final to earn an A in the course? Is this possible? Well, when taking an average, you start by adding up all of your scores, and then you divide by the total number. So if we already have an 81 and an 89, that's two of our scores. However, we don't yet know what the final exam score is, so let's call that X since it's an unknown quantity. With those three scores, to take the average, we need to divide them by 3. And to earn an A in the class, we have to get at least a 92. At least is greater than or equal to 92. Now from here we can simplify. 81 and 89 gives us 170. So it's 170 plus x divided by 3 is greater than or equal to 92. In order to solve this, let's multiply both sides by 3 so we can cancel out the denominator. So we have 170 plus x is greater than or equal to 276. And then of course subtract 170 on both sides. So in order to earn an A in the class, we have to score at least a 106 on the final exam. Now, is this a possibility? Assuming that there's no extra credit on a final exam, we cannot score over 100%, which means that no, this is not possible. Last up, let's take a look at some temperature conversions. Temperature conversions still fit into the algebraic category because you're using an equation that is given in order to go between Fahrenheit and Celsius, so degrees Fahrenheit, degrees Celsius. If I want to convert 84 degrees Fahrenheit into some amount of degrees Celsius, I have to choose the correct formula. If we're looking for Celsius, we want to go for the formula that has C equal to the rest of this. Now, that's not to say if you picked the incorrect formula, you wouldn't be able to still get the same answer. It would just require more algebraic manipulation. So let's plug in what we know. Celsius is equal to 5/9 times F is 84 minus 32. So C equals 5/9 times 52, which doesn't end up being a whole number, so let's round that to one decimal place. This gives us 28.9 degrees Celsius. So 84 degrees Fahrenheit is approximately 28.9 degrees Celsius. And we can repeat the same process. Again, choose the correct formula. This one we're converting from degrees Celsius into Fahrenheit. So I'm going to select the first equation that has F equals. Degrees Fahrenheit is equal to 9/5 times negative 2, because that's our degrees Celsius, plus 32, which gives us negative 18 over 5 plus 32, which is negative 3.6 plus 32, simplifying all the way to 28.4 degrees Fahrenheit. So negative 2 degrees Celsius is 28.4 degrees Fahrenheit. Thanks for watching.